Okay, good afternoon, everybody, or good evening, as the case may be. This is the third talk I've given today, so please excuse any glitches. This really comes out of a current grant project that I'm working on with the CISA3 group, the Center of Interdisciplinary Science for Art, Architecture, and Archaeology. And I'm the archaeologist, the last part of that acronym. And we were lucky enough to compete for one of the new CSRO grants that Cal IT has enacted. That's the Cal IT Strategic Research Grant Program. And this is what is going to be the focus of my talk. And these are all the collaborators that are graduate students, both in anthropology and computer science, and people on the staff here at Cal IT too. And the way to envision our approach to cultural heritage is that we're coming at it as archaeologists. And so I like to use this model as a way to kind of highlight what some of the emergent trends are in world archaeology that touch on the issue of cultural heritage, of which the archaeological record is a central part. And so the kinds of problems that we're encountering in our research are similar to what archaeologists all over the world are having trouble with, and that is the inexpensive nature of so many digital technologies. They're so readily available for us to use that it's creating a data avalanche. But the thing to remember with us as dirt archaeologists that interface here with our colleagues at the Center of Information Technology is that what drives our research is the content, the archaeological questions, the anthropological questions, the historical questions. That's what it's all about. And we are able to collaborate with our engineering colleagues and our computer science colleagues to help us find solutions for understanding that content. Now, as archaeologists, we have there are two central issues that are what we could call our most precious commodities. And one is space, that is the spatial location of artifacts and material culture. That means that if a thief digs up an archaeology site and finds a really nice gold vessel or a wonderful tablet and rips it out of the ground, it loses all its cultural context. And it's almost, in many respects, it's meaningless. And so as archaeologists, that's why we dig so carefully. But with new technologies that we can develop and adopt, we can control the spatial location of those data. And the best way to organize those kinds of data sources is through geographic information systems. Our next important variable to control is time. Because if we want to measure culture change, and that's what this is all about, the archaeological enterprise, we need sophisticated tools for measuring time. And that comes from high-precision radiocarbon dating. That's not something that we do here at Cal IT, but we can collaborate with other labs, like the Oxford Radiocarbon Lab we work with, or the NSF labs in this country. But Cal IT, when it comes to digital data of any kind, is at the forefront of this new frontier. And that's what we can focus our efforts on here. The next step is, well, what do we do with those data? What do we do with the analyses? We have to deliver it either in conventional printed matter or over the internet, and so we develop different kinds of cyber infrastructures to get that data out there, to organize it and to get it out there. And so one of the things that we're doing here is trying to organize our field data that we collect in the field and how to make that readily available for analyses and interoperability. And the result of all that is the conservation of the past. We have these wonderful digital records and so on that create frozen moments in time, and they preserve all the different kinds of records that we create. Now, what this ends up doing is it creates what I like to call a 21st century data avalanche. And we are facing this as field scientists, as archaeologists, but I think these are the same kinds of problems that our colleagues in geology or ecology face. And so we're a kind of testing ground for how to deal with this. As I mentioned, as archaeologists, we still excavate like our 19th century predecessors. You can't develop a robot to do this. At least I don't think so yet, but maybe you'll convince me that it is possible. But meanwhile, we use undergraduates, and they work really well. And I see one of mine is in the background there. What's really changed is our ability to record the spatial context, the cultural context of those data. And I'm not going to go through this flow chart except to just point out that, you know, the excavation effort is always driven by our research questions. We don't go out to dig just to dig, but we have questions, historical or social evolutionary questions. And then we have different kinds of digital recording tools, an array of different digital cameras from still to video. We have different kinds of surveying tools that are rooted in GPS or total stations. Now we, as you may have seen out here at near the Bear today, we were flying our balloon with our stereo digital camera imaging system that we used in Jordan last fall, and it was featured in the National Geographic Nova show that showed on public television last week. That was something that was developed by Cal IT undergraduates, undergrads from the Department of Aerospace and Engineering, who, it just so happened my wife saw an article written about Professor Kosmatka's work. You know, he's put up a balloon 85,000 feet. Well, I only need to go about 400 feet, something like that, 500 feet. But anyway, I contacted him, and through Cal IT, we got some major funding to develop what you see out there. And that enables us to do on-site mapping on a daily basis and to record the progress of the excavation on a daily basis and to record these cultural sites for posterity. We also implement new kinds of data recording techniques, relatively new, certainly new to archaeology, and that is LiDAR, a way of mapping sites in 3D that we'll go over shortly. Now you can get portable X-ray fluorescence instruments to characterize the elements of any artifact. And it looks like a gun. Getting it through customs can be a problem, but the point is these are portable, and there are over 500 museums and anthropology departments around the world using this. Well, how are we going to integrate all these data? They have different file formats and so on, and so that's where our CSRO grant is helping us, and I'm collaborating with Yuma Matsui, who's in the audience, and Tom DeFonte's research group on helping us solve that data. And in the end, all of these can come together and be presented over the internet in standard book form or in the new kinds of 3D visualization theaters that are rapidly becoming available and are being developed here, especially at Cal IT. So to pull all these different data sources together, the key is simply XYZ coordinates. And we've been sort of pre-adapted for that in our research, because back in 1999, I decided that we would go digital in our recording. So every artifact, every spatial context that we record gets an X, Y, and Z coordinate, Z for elevation, so that we can pull it together in a GIS system. And that pre-adapted us to 3D visualization of our data. And some of you have seen some of those demos today. The new thing is going to be to pull this together so that we can analyze these data in real time in 3D with some of the new visualization tools that the Cal IT 2 lab is developing, such as the Nexcave. This is our research area that you see here. We're working in Jordan, just opposite Israel. We're about 50 kilometers south of the Dead Sea, 50 kilometers north of Petra. How many people here have been to Petra? My wife and my student. All right. All right, what can we do? Huh? How many people want to go to Petra? All right, so you're going to go and you're going to participate in our expedition in the fall. There we go. And you're going to have a 5-star tent here. This is where we live for 2 months a year out in the field. But we're on the edge of a Bedouin village which has electricity. So we can basically duplicate our digital archaeology or cyber-archaeology lab that we have here at Cal IT in the field. And so that's what we do. And this is the research area. It's in the hyper-arid Sahara-Arabian desert zone here, but over a very narrow area of about 25 kilometers, there's 4 different ecozones, from a narrow belt of Mediterranean land to a narrow belt of semi-arid land, until we get into something that's very much like the Anza-Borrego Desert. This is an aerial photo that I took back in 1999, thanks to Queen Noor of Jordan. She was the wife of King Hussein, the late King Hussein, and a friend of mine said, you know, Queen Noor really likes archaeology, so why don't you send her a fax? This is before email was really prevalent, and ask her if you can borrow a helicopter. And I did. See, if you're going to be an archaeologist, you have to be what we call a schnorrer. You know, you have to just constantly ask for stuff, and that's the way you get it. So we had 1 day of airtime, very expensive, and that's when I decided we really needed to have our own system. It wasn't until, I've been on the faculty here for 18 years, but it wasn't until 5 years ago that I teamed up with Cal IT that we were able to actually do this. And this just shows you that, you know, our content is driven by anthropological questions and so on. But we're not going to go into that here. This is a kind of model of where we're almost at in applying different kinds of digital technologies in our work. You can see this is not me. This is Harrison Ford, who's been photoshopped in there. But he's standing in front of an optoputer. It's a very powerful computer system that enables real-time telecommunication and the integration of different kinds of data sources, like these 3D scanners that we actually use in the field to record our artifacts in 3D. And remember, all of these data have their georeferencing. Then we have our regular digital photography of artifacts. And by the end of the season, we'll record about 6,000 different artifacts. We have our portable XRF over here, which we now bring into the field with us. And then we have a Panasonic Toughbook for a live feed of our stereo digital imaging of the site with our balloon proudly flying the Cal IT flag over here. And here's our LiDAR scanner over here, and this is a robotic total station for measuring individual data points. And this is something we still want to get. We don't have it yet. But this would be in the Bedouin village where we download all the data. This is what it looks like out on the archaeological site. Here you can see some of our students, a grad student, Tom Whippich, and an undergrad last fall when we took the LiDAR scanner, which is part of the Cal IT toolbox here. It's a light detection and ranging laser. So what it does, it'll scan a site and it will record millions of data points. A total station will record one data point, X, Y, and Z. This will record in one scan 300 million of those data points with X, Y, Z, plus or minus, in accuracy, plus or minus 1 millimeter, and it gives you color. So this opens up a whole new area of possible data analyses. Let's see if this will work. Well, I like to use a little Arabic for flavor, okay? But what we're doing is we're flying through this ancient fortress of Khirbat al-Nahas, which in Arabic it means the ruins of copper. And through high-precision radiocarbon dating, we have located this in the 10th century BCE, the time of King David and Solomon. And this was featured in that, this data wasn't actually in the film that was on Nova because Tom Whippich showed up late, you know, but never mind. But that gives you an idea of one of these data sets that we can drop. Now we can drop our GIS data into that. And it gives us a beautiful model of the entire Iron Age fortress that existed in the 10th century BC. We can also use the data that our students collected with the balloon system that you saw flying here to do this.
The site is so large, they send up cameras attached to helium balloons to get a
And these are the two undergrads, David Hernandez and Alan Turchich, who are in the middle of finals week, and I forced them today to fly the balloon. So if there are any professors of aerospace, please have compassion. Right?
The aerial photos clearly reveal the structures of the ancient factory. A fortress and gatehouse. An administrative building. A tower. A temple. The site was enormous. Its massive walls, buildings, and slag heaps covered an area of 25 acres. Up to
So National Geographic NOVA used the stereo digital imaging that we collected last November to make that reconstruction. There was a company in Washington, D.C. that did it. But these are the kinds of projects that we involve our undergrads in to really push the envelope. Now, what all this does is it creates this data avalanche. So if you look at these different recording tools on the left, like the 3D scanners, the high-res artifact photography, gigapan photography, GIS, video, the whole thing. In 2007, we collected 172 gigabytes of data. By last fall, when we brought in some of these new tools, we were bringing home 1,370 odd gigabytes of data. So this is the kind of thing that all archaeologists, probably geologists and other field scientists are encountering. Thanks to the collaboration between Cal IT and KAUST, which is the King Abdullah University of Science and Technology, Cal IT got one of the small research grants from this university in Saudi Arabia. And Tom DeFonte Tom DeFonte's the PI, and Jürgen Schultz is another co-PI, and this was something that Ramesh Rao really helped pull together. The small grant was $8 million. Okay, I don't know what the big ones were over 40, I think, something like that. But Cal IT was awarded the grant to build a scientific visualization lab very similar to the one that you can see downstairs here, the Cal IT VisuLab, for them, only it's 3 times bigger. I don't know if it's better, but it's certainly bigger, and they have a lot more, there's a lot of cool hardware in there. Okay, and one of the things that Tom and his group have developed is this 3D imaging theater, which is less complex and more portable than the Star Cave that many of you may have been in. And this was developed and designed with the help of Greg Daw. And this is the kind of platform that we want to build, a portable replica of this to be able to take into the field with us in Jordan. And that's what this program is about, the CSRO program, to enable us to do that. And we were able to demo a lot of the 3D data that we collected in Jordan on this Nexcave system for the opening day celebrations of KAUST last September. So, so that gives you an idea of how at Cal IT, by doing this kind of collaborative research between traditional field archaeology or field scientists and state-of-the-art information technology, can really have a lasting impact on the way that we do scientific research. Thank you very much.